Hi, this is Stephen Brower from Martin Valley Community College. This is for CSIT 256 Computer Architecture and Assembly Language, and this is for looking at RAID, Redundant Array of Independent Disks, and this is for Stallings Chapter 6. This is Take 2. So, what we'll look at within this video are three levels of RAID. RAID 0, also known as striping, RAID 1, also known as mirroring, and RAID 6, which we'll get there, but it has a dual block parity that's distributed across the disks. What this video is not going to get into is 2 through 5. Our book does have it, and it shows sort of the evolution that took place. But the reason why I'm jumping to the RAID 6 is because that one is used by a number of businesses. There are high levels of RAID that are also used as well, but I just want to at least get across the concept on this one. So the idea behind striping, which is RAID 0, is that we can use multiple drives to make it seem as if we have a larger drive. So in other words, let's say we wanted a 1 terabyte drive. Instead of using one big drive that's 1 terabyte, we actually can use two 500 gigabyte drives. And so the idea is that the RAID circuitry is what will handle what we're about to see in terms of the writing and the reading in terms of the disks. From the operating system point of view, it looks like it's just one drive. So when we're writing data, it's going to get broken down into little pieces, and in a sense, it's going to be those strips, and it'll start writing, stripe 0, 1, 2, 3, and so they are distributed across the disks. From a writing point of view, so if I actually just back up for a second, let's just pretend that this is a bad exaggeration, but let's just pretend that this is 1 meg in size. And if we break it into 4 strips where each one's 250K, well, simultaneously we can write 250K and 250K, and then 250K, and then 250K. If we had 4 drives and we were able to split the 4 stripes, then we could simultaneously write the 250K. Again, I'm just exaggerating with these numbers, but what I'm trying to get at is one of the benefits of RAID 0 is fast writes, because we're writing simultaneously to more than one drive. And so the writes can go a little bit faster. Now, the downside of RAID 0, well, first of all, if you only have one drive, the huge downside is, what if you lose a drive? Well, if we have RAID 0 and we're striping, what happens if we lose a drive? Well, if we lose a drive, I can't get to strips 1 and 3. So if we lose a drive, we're dead in the water. We're not fault tolerant, meaning we can't tolerate the fault of one drive crashing. So the striping, again, the benefit is we can have multiple drives that will seem like logically one drive. Mirroring, now the idea in mirroring is that however many disks that we want, in other words, if we want 1 terabyte, we're going to have double the amount of disks. So if it takes 2 disks to be 1 terabyte, we need 2 times 2 or 4 disks in order to do it. And so that each drive is going to have a mirror. Each drive is going to have a mirror. And what the circuitry, RAID circuitry, will do is when it's writing 1, it will write the mirror simultaneously. When it's writing 1, it will write the mirror simultaneously. And so if this is the block of data that we want to write out, yeah, it's broken into those strips, but then strip 0 and strip 0 is mirrored, strip 1 and strip 1 is mirrored, strip 2 and strip 2 is mirrored, strip 3 and strip 3 is mirrored. Now, an advantage of mirroring that striping didn't have, if we lose a drive, we're okay. That because if here's strip 0, there's strip 1. And if here's strip 2, there's strip 3. So in terms of fault tolerance, we can handle losing one drive. And actually, if we're talking about losing a second drive, if we were to lose a second drive, well, what would be catastrophic? If we lose this one, it's bad. But if we lose this one, or if we lose this one, we're still okay. But in terms of one drive going down, we can handle a single drive going down. And that means that the system will continue to run. Now, what would happen is on a server that is using mirroring, they actually can send, well, in the old days we had these things called beepers, but it can send a text or an email to whoever the support person is and basically say, okay, we have a bad drive. Well, what RAID 1 also introduced was the concept of hot swappable. And the idea of hot swappable, we can yank the bad drive out, put a fresh drive in, and then the data that was on the mirror will eventually get written back to the drive. So not only do we have that it's fault tolerant, that we can stand losing a drive, but the hot swappable idea, you pull out a bad drive and put a good one in, and it'll eventually write the data over to that drive. Between RAID 0 and RAID 1, so striping and mirroring, that is available from some computer manufacturers. Like if you go to Dell and you want a desktop, you actually, some of the desktops have two 500 gig drives. And what you can do is you can say whether you want striping or mirroring, RAID 0 or RAID 1. So on the time when you buy the drive or when you buy the computer from Dell, you actually tell them how to format it, how to set it up. And so this way you can decide if you want the space, you can get a terabyte. So RAID 0, you're going to get use of both of those drives in terms of total space. If you want RAID 1, you only get 500 gig. But if you do lose a drive, then you already have a mirror. So what used to only be in business now has worked its way down to the consumer market, and that RAID 1 is something, RAID 0 and RAID 1, we can get at home. Now, what I'm skipping over that the book has, and I'm not, it's not that it's not important, but when you look at RAID 2, 3, 4, and 5, you can see the natural progression that kind of went through how to basically use fewer disks and also not to beat up a disk. There's one of the levels where there's a designated parity drive, and that one's beaten to death because it's always being referenced. Well, in RAID 6, suppose we want 2 terabytes of storage, and 2 terabytes would be 4 drives. Well, we would need N plus 2. We would need 2 extra drives to take care of the redundancy that's needed. And what RAID 6 will do is it's block level parity, and there's 2 of them. So if this is the data that's going to be written out, it'll be created into 4 strips and additional 2 parity blocks. And so the idea is if these strips here, 0, 1, 2, 3, if this strip here is a chunk of data, then these are the parity bits that get associated along with them. Now, that parity is going to be distributed in the sense that the next strip that's being written, the parity will be shifted a drive. So for this one, 4, 5, 6, and then 7's over here, and then this is where the 2 parity blocks are. So the next strip then, P would be here, Q would be here. And so it's distributing the parity so that one drive isn't being overused in terms of like being the parity drive, as it were. It is fault tolerant, so we can lose a drive, and because of the parity, now I'm only highlighting one here, we have 2 parity blocks. But if we lose a drive, then we only need one of the parity blocks to figure out what is the data that we are missing. Again, fault tolerant, we can continue to run. It is hot swappable. We can pop out that hard drive, pop in a new one, and then the circuitry will copy the or rebuild the data based on the other blocks that are there. And the other thing that we can do in terms of RAID 6 is we can lose 2 drives. Now, in the case of doing 2 drives, if we look at the first strip going across, well, here's 0 and here's 3. Well, these 2 parities will take care of the 1 and the 2. And the second strip, here's 4 and here's 7. These two parities will take care of the 5 and the 6. So we can handle 2 drives that go down. So RAID 6, it's N plus 2 disks. It's a block parity. It's dual because we have two parity blocks, and it's distributed so that we're not beating the same drive over and over again. I think that's it. The next one should be blank, right? Yeah, okay, good. That's it.